All right. Hello and welcome to the KubeBuilder controller runtime and controller tools meeting for, what day is it? Probably should have looked that up before. Thursday, May 20th, 2021. As a reminder, this is being recorded and will be posted to YouTube. So, don't say anything that you don't want posted to YouTube for all the world to see. All right. So it looks like we have a pretty short agenda today. So we have two items. I think the first one is from Kevin about the conditional controller design. So Kevin, I'm going to hand it over to you.
Thanks, Solly. Yeah, so this is something that I think has been in discussion for a while, and the kind of design that was approached a while ago hit some hurdles with kind of some upstream stuff. But I just kind of wanted to first kind of revisit that, and before diving into the actual design, just kind of discuss the use case and try to understand if you all in controller runtime are supportive of kind of supporting this. And so the idea here is that more and more people are writing controllers where the controller is not running on the same cluster that it is controlling, and it could be controlling multiple clusters. So like when this is the case, the operator admin who writes the controller, who runs the controller manager, is different from the cluster admin. And when that's the case, I don't have any control over what CRDs are installed on the cluster. And so if the CRD that my operator is watching isn't installed when the operator starts, it'll just error out with a meta no kind match error. Or if the CRD gets uninstalled during operations, the informer will just spam logs and spam the API server with list requests that'll always fail, and could DDoS the API server effectively. And so basically what I'm trying to ask is, do we want a solution for gracefully handling when a CRD gets uninstalled from a cluster that my operator is operating on? And if so, then that's kind of where the design that I've offered in as you can see in the doc. And I can discuss more about that, but I think I just first wanted to start a conversation around that use case and see if we're on board for that, or if there's objections to that.
So I read through your proposal real quick just in the few minutes before this meeting started and the discussion started. What was interesting to me in particular is trying to map this to the multi-cluster story. I wasn't 100% clear, again, just on a quick first reading of this, how comprehensively we want this to fit into a multi-cluster story. I've admittedly not kept up recently with what controller runtime is supporting as like a first class kind of support for accessing multiple clusters at the same time. But that seems like the critical point, the critical side of this to me. If we were just talking about a single cluster, like I'm just running a controller in a cluster, watching resources in that cluster, and on rare occasions, APIs come and go and I need to deal with that, like that seems like we might take different or simpler approaches than what's here. So I don't know, can you maybe elaborate a little bit on how you see this fitting into multi-cluster support in general?
Yeah, so I think you're right that the guidance that has previously been given on this use case is definitely used like a simpler to like run different operators kind of approach if you're only running on one cluster, and kind of the need for this really comes from that multi-cluster case. And I guess so I think the way that we've been thinking about this is that there's no good multi-cluster story in controller runtime currently, and hopefully something like this can serve as kind of the first step in making multi-cluster more supported. I guess, Solly, correct me if I'm wrong, or if I'm saying anything that doesn't make sense, but this, the current, in the multi-cluster case, basically, if you wanted to do something like this, you would need to have some sort of orchestrator of controllers that can get kind of clunky, and this provides a built-in way to handle that. Solly, I don't know, what would you add there?
Yeah, I mean, well, so to be clear, we've had a little bit of previous exploratory work around multi-cluster. I think there was some initial work around separating the cluster object, kind of like the cluster connection details, from the manager object, so that you could theoretically instantiate a manager and like have clients from that manager that connected to multiple controllers. I think one of the things, just to kind of supplement what Kevin said, is one of the patterns that we've seen with some of our internal users is kind of an approach where we have like a multi-cluster manager that runs a bunch of sub managers per cluster, basically. And so like the idea of crashing the entire binary when an API comes and goes is like, that's not really going to fly for that use case. And so like one of the things that we would like to do is like kind of make that use case a little bit more viable, so that you can have that kind of, some sort of, and this is like a pattern I've also seen externally for a couple of users before. Like you can have that multi-cluster manager binary and kind of just like easily not have to worry about APIs coming and going. Does that make sense?
That makes some sense to me. I wonder if you could comment on, like, is there a viable option in there, based on what you've seen, to have a boundary at this sub-manager layer where, like, I might naively just think, I'm going to create this sub-manager that is going to interact with a particular cluster. So I think there's a sub-manager per cluster that I'm talking to, perhaps. And if something changes about that cluster, like new APIs appear that I need to start dealing with, or if APIs go away that I need to stop watching, I might just restart that manager. Like, not worry so much about reconfiguring and doing these kind of changes, but what if I just actually let it exit or return out of that manager and start a fresh one? Is that possible?
I mean, you could theoretically do that. The places it starts to get more clunky is if you have like multiple controllers running in that manager sharing a cache, which is a pattern that we have to some degree encouraged, right? Like run all of your managers in a binary because they're using some similar resources. Like you have two controllers, or sorry, run all your controllers in a single binary because, like you have two controllers that need to look at pods, might as well share a pod cache, stuff like that. So like you theoretically just restarting is fine. Practically, that could be a disruption of service. It's probably not a huge deal. We would also like part of the work, like I think Kevin has put in, is making the flow a little bit easier, so you can declare like this controller is conditional on this API existing or whatever. And so I think in either case, we'd probably need to have like doing that right now without like kind of support in controller runtime, we found to be a little bit clunky. So like in either case, I think we need to have support for that. Like we need to, or we want to like make that a little bit easier, I think at least. The under the hood details, theoretically, we could just restart the whole manager. I think it's a little bit more clunky, but
yeah, it's definitely more clunky. What I like about it is like the just complete simplicity of it. I think it fits other declarative kind of patterns and immutability kind of patterns. Like when things change, rather than trying to like keep up with every incremental change, let's just start something fresh. It also assumes that these are going to be rare events. Like APIs coming and going from a cluster is presumably a rare thing. We know that our entire process is going to get periodically restarted anyway, just based on upgrades or getting node maintenance, getting migrated from one to like this kind of stuff. So like occasionally, having to lose out on the cache and start fresh, especially if it was only one cluster's worth, seems like an acceptable thing if it's worth it. Maybe it's not worth it, and maybe this kind of deeper approach to a deeper understanding of what APIs are coming and going and what controllers and what caches correspond to those APIs, and trying to like carefully restart the right things. Maybe that's worth the effort, but just wanted to at least explore what I think could potentially be a simpler alternative.
yeah, that's a fair point to bring up. I think there's also like these are like there's at least one kind of optimization benefit to this approach as well, which like it is kind of strictly an optimization, and it only applies in certain use cases. But if for some reason you are concerned about the number of requests you are making from your manager binary out to a given API server, kind of hot looping on an API that doesn't exist isn't great and doesn't in certain cases. And so like the other nice thing about this here is it like compared to some of our traditional approaches is it stops that. Restarting the manager would probably also help with this. We'd probably end up using the same signals. And then we just have to block the manager, I guess, block the manager from starting or block the particular controllers from starting until the API appeared. I think I would be idly curious to see how much actual overlap in the code is, because we'd probably still want, like a lot of the work Kevin has done, I think in this PR, is plumbing through, figuring out how to plumb through the signals that we need to deal with like stopping and starting the controllers. And we need those same signals for the manager. I suspect a lot of the complication, it's a lot of the deeper approach would kind of have some overlap with the restarting the manager approach, just from that perspective of we still need to plumb through the signals. We still need to be able to detect, hey, this thing has gone away. Hey, we're waiting till this thing appears, stuff like that.
Yeah, that makes sense. I've definitely seen, and I think maybe even a couple times have done at least half of that pattern of, and probably some others have seen this as well. Like a particular controller at startup, like in your main.go, at some point you'll use the discovery API and like put it in the loop, like wait for some API to appear if it ever appears before starting this controller kind of stuff. That side's relatively straightforward. Probably the API going away is more difficult.
Yeah, it's straightforward, but it's nice. I think we're seeing it enough now, at least. I can't speak for everyone else on this call, but like it's something that I think I've encountered from a lot of our internal users, is like that kind of desire to wait. And so like encapsulating it in an easier to set up a pattern seems like it would be valuable, even if it's not terribly complicated off the bat, just making it a little bit easier, and being able to tie in with the stop, right?
Okay, yeah. So it sounds like I think that the restarting the manager idea is interesting and worth me looking into, if that simplifies it, or just kind of at least spelling out in the design why that might or might not be better or simpler. And I'll try to spell out more also around the kind of multi-cluster, how this fits into multi-cluster, or like what it would mean, and probably go from there and maybe revisit when that's more fleshed out. But also feel free for anyone to take a look at the design and the proof of concept itself and offer feedback on that.
All right. Unless anyone else has any comments, I think we can probably move on to the next thing. This should be hopefully quick. I don't know if, as y'all may or may not have noticed, there is a new tool in the controller runtime library for helping to manage NFS versions. So for people who maybe aren't familiar, we stopped bundling NTest with KubeBuilder for KubeBuilder v3, which just released a few weeks ago. And right now, KubeBuilder projects are generated with this script, or use this script that lives in controller runtime, the shell script, to download appropriate versions of the NTest tools like Kube API Server, netcd, and kubectl. And this is not great from a number of reasons. First of all, I think perhaps most of us, if not all of us, can be in agreement that running arbitrary scale ships from the internet is maybe not the best. And there are all sorts of weird issues with shell compatibility that occasionally hit and stuff like that. And the other thing is, like, historically, it's been hard to discover what versions of MTest binaries we have built and what's available for download, and kind of managing those. Especially if you're like me and you need to flip between versions on a somewhat frequent basis, debugging issues, seeing if something happens with with one version of the Kube API server but not the other, or something like that. And so we went and wrote this tool, set up MTest, and the idea is hopefully it'll eventually make its way into KubeBuilder, but in the meantime, we'd like people to try it out. So I can give a little demo of how it works, and talk about how it works, and yeah, see if anyone has any questions. Let me share my screen. I can share a window. Great. Can y'all see this well? Font size big enough?
Yep,
Yeah, it's fine for me.
Wonderful. All right. So it's, the idea is hopefully it's pretty easy to install. It lives in its own module inside controller runtime, so you can just go install it. I already have it built, so that was a quick install, but it's not huge, so it's pretty quick anyway. And then it's on our inner path like normal. All right, so if we run the command, we can kind of see, added some help and some examples. But the idea is that we can go and list. So mtest list, we can see all available versions. You can see I have two versions installed, 119 and 120. And then I can say use, and I can say like 1.20. You know what? That's going to cause an issue. I have a shell script set up that wraps this a little bit for my personal environment. Let me actually just use the binary directly so you can actually see what's going on. So what you can see is that it kind of downloads them into a cache. The cache is operating system specific, so it'll put it in the appropriate place for your operating system for app data, basically. And you can switch between these versions easily, and it'll print out. You can tell it to either print out information, or you can tell it to print out a path, just the path, or you can tell it to print out a little shell script type thing that you can just source like that. This will accept all sorts of selectors. So if I want to, like, say the latest version greater than 119, or if I want to say like about 119, I can say 1.19. And I'll select the latest version. If it's not available, it'll go download it. It'll attempt to go download it from our kind of GCS buckets where we host all of this stuff. And then, of course, there's also a delete command if I wanted to clean up versions and stuff like that. Yeah, so hopefully that should make it a lot easier to manage your MTest binaries and make it so that you don't have, like, if you work on like 5 or 6 different projects, you're not like, and they all use 119 by default, you don't have like 7 copies of 119. You just have this one centralized copy that's sitting around. Does anyone have any questions? Oh, I should mention too, for people who are concerned about offline usage, there are flags and environment variables that can configure it to only use offline versions, or to look at a different source, or allow you to sideload tarballs in the format we expect into kind of the internal cache, so that you could theoretically sideload, private versions, or if you wanted to work in an air-gapped environment or something like that. Anyone have any questions? See some examples there. All right. If not, hopefully, please give it a try. Let us know if it, breaks on your operating system, or if there's some weird use case that doesn't work for you, or if you just find some sort of flag completely unintuitive or something. Let us know. We're currently considering it kind of in an alpha beta stage, and hopefully we'll promote it to stable-ish as well and start using it in KubeBuilder and etc. All right. And with that, I think, unless anybody has anything else they want to say, pause for a moment just in case. All right. Have a wonderful rest of your day, and I will see y'all in 2 weeks.
See ya. Thanks.
Thanks, bye.